Today, agriculture generates more data than ever before. Yet many problems remain invisible until it is too late. This is the story of our project, Integrated UAV and Sensor Ecosystem for Smart Field Management. In this video, you will see how our system operates under real greenhouse conditions. Our first destination is Masalke Strawberry Farm, located in Saffron Village, Yalova. Every strawberry plant tells a story, through its leaves, its environment, and the subtle signs of disease that emerge over time. Our goal is to detect those signs before they become visible to the human eye. To achieve this, we combine three technologies: an autonomous inspection drone, a network of sensor kits distributed throughout the greenhouse, and an AI model working in the background. The sensors continuously monitor greenhouse conditions. When abnormal values are detected, the system automatically assigns an inspection mission. The drone is then deployed to investigate the area. Behind the scenes, multiple technologies work together to operate the system. The LoRaWAN gateway collects data from the sensor kits. The VRX receiver receives the live video stream transmitted by the drone. One computer processes the incoming visual data, while the second computer manages the user interface and mission control operations. The entire system can be monitored and controlled through a unified interface. Within the agro section, users can view sensor measurements, sensor locations, and disease detection records. The location of every sensor kit is displayed on the map. Whenever an abnormal condition is detected, the system immediately raises a visual red alert. This allows critical areas to be identified within seconds. Users can also customize sensor thresholds directly through the interface. The drone control panels provide access to telemetry information, flight data, PID parameters, and mission management tools. When a sensor kit reports abnormal measurements, the system automatically highlights the corresponding area. A mission is then generated within the mission section. The platform calculates a recommended route to the target location. Once approved by the operator, the mission begins. At this moment, the system is assigning a mission to investigate a region where abnormal environmental conditions have been detected. Now, we can see the drone is preparing for takeoff. The mission has started. The drone is now navigating toward the target location. Its purpose is not simply to fly. Its purpose is to scan the alert area provided by the sensor network. Once it reaches the target location, it captures high-resolution videos of the crop. These video immediately processed by our artificial intelligence model. Whenever a disease is detected, the corresponding image is uploaded to the cloud infrastructure and transferred to the interface. Meanwhile, an irrigation event takes place inside the greenhouse. Environmental conditions begin to change. Soil moisture increases. Other parameters gradually respond to the new conditions. Following irrigation, the system analyzes the updated sensor data. Based on these changes, a second mission is generated. The drone is once again deployed for inspection. The model has been trained on thousands of agricultural images collected and labeled. It was specifically developed to identify common strawberry diseases. During flight, every frame is analyzed in real time. During these tests, the system successfully identified two different plant diseases: powdery mildew and gray mold. Now, we move to our second testing site. Located in Cementla Village, Yalova, this greenhouse is facing significant production challenges. A large number of plants show visible disease symptoms and severe deterioration. For this reason, it provides an important environment for evaluating the system under more demanding conditions. Our setup operates here in exactly the same way. The sensor kits collect environmental data, and the drone performs targeted inspections whenever necessary. The gateway maintains communication across the network. VRX transmits the real-time images from the VTX on the drone to the screen for model processing, and the supporting infrastructure continues operating in the background. Abnormal sensor readings once again trigger a new mission. The drone takes off and begins inspecting the designated area. As the live video stream is analyzed in real time, the system identifies additional disease symptoms. The resulting image is automatically transferred to the user interface. The results of this project demonstrate that environmental data and visual observations can be integrated into a single platform. Abnormal conditions can be detected automatically, risky areas can be investigated through autonomous drone missions, and artificial intelligence can support disease identification. The system is not limited to disease-related cases. It can also be used for data monitoring, periodic drone patrols, and different agricultural inspection scenarios. We would like to express our sincere gratitude to TÜBİTAK, Yıldız Technical University Kashifler Program, and our advisor, Professor Dr. Vasfi Emre Ömürlü, for their valuable support and guidance. We also thank our sponsor, Sabri Bozkurt, one of the founders of Agromini, as well as all the farmers and growers who welcomed us into their greenhouses and made these field tests possible.